Good day, everyone. Today you'll be learning about finding the nth term or the general term of the sequence. So what is a sequence? A sequence is simply a set of numbers in a particular order or a set of numbers which follows a pattern. For example, using abstract reasoning, find the next two terms of these sequences. Pause this video for a while and think of your answer. If you already have the next two terms, so what if you're asked to find the 100th term, or the 150th term, or the nth term of a sequence? Do you think listing all of the values from the first term until the 100th term? I guess not. So in this lesson, we will be creating a formula out of the given sequence. How? By following these easy steps. Steps in finding the general term of a sequence. First, make a table of values, n for the domain and an for the nth term. Second, find the common difference. Third, using the table that you made in step 1, use the general formula for linear, quadratic, or cubic sequence to form an equation. Fourth, solve for the unknown variables. Fifth, substitute the values to the general form to obtain a formula in finding the nth term. So let's start with linear sequences. Is a sequence whose first difference is constant or common. Example, find the general term and the 30th term of the sequence in example A, number 5. Number 2, find the general term and the 75th term of the given sequence in example A, number 3. So let's answer number 1. So remember the step 1, make a table with a heading n and an, where n represents the domain and an which represents the term value. So if our n is 1, so if our first term is 1. If our n is 2, our second term is 3/2, and so on. Step is get the first difference by subtracting two consecutive terms. So 3/2 minus 1 is equivalent to 1/2 and 2 minus 3/2 and so on. So their common difference is 1/2. Let's move on to step 3. Using the table that you made in step 1, use the general formula for a linear sequence to form an equation, and it is ax plus b is equivalent to an. So if n is equivalent to 1, our an is 1. Substitute, we have a plus b is equivalent to 1, and it is our first term. And if n is equivalent to 2, our an would be 3/2. So substitute, simplify, we have 2a plus b is equivalent to 3/2, and that will be our second equation. So for our step number 4, solve for the unknown variables. Using elimination method, we subtract equation number 2 and equation number 1. So 2a plus b is equivalent to 3/2 minus a plus b is equivalent to 1 is equal to a is equivalent to 1/2. To find the value of b, we substitute the value of a to either equation number 1 or equation 2. And I choose equation number 1. So a plus b is equivalent to 1. Substitute the value of a. We have 1/2 plus b is equivalent to 1. and use additive inverse so that I can eliminate 1/2 so that b will remain. So b equals to 1 minus negative 1/2 and b is equivalent to 1/2. Therefore, the value of our variables is a is equivalent to 1/2 and b is equivalent to 1/2. So for our step number 5, substitute the values to the general form to obtain a formula in finding the nth term. So, remember, our general form is an plus b is equivalent to an. Substitute the value of a and b to the general form. We have 1/2 n plus 1/2 is equivalent to an. Therefore, an is equivalent to 1/2 n plus 1/2 is the general formula. To find the 13th term, we substitute n is equivalent to 13. So, our general formula is an is equivalent to 1/2 n plus 1/2. So, if n is 13, an is equivalent to 1/2 times 13 plus 1/2. So, an is equivalent to 13 over 2 plus 1/2. Therefore, an is equivalent to 14 over 2 and an is equivalent to 7. Therefore, the 13th term of this sequence is 7. So let's try this. Follow the steps in finding the general formula of a linear sequence and answer number 2. You will find the answer key at the end of this video. So let's move on to quadratic sequences. How about quadratic sequences? How does it differ from linear sequences? A quadratic sequence is a sequence of numbers in which the second difference between each consecutive terms differ by the same amount called the common difference. Example: find the general term and the 40th and the 51st term of the given sequence in example A number 7. 2. Find the general term and the 6th and the 16th term of the sequence in example A number 6. So we will answer number 1. Remember step number 1, make a table with the heading n and an where n represents the domain and an which represents the term value. So if our n is equivalent to 1, our first term would be 4, and so on. Step number 2, get the first difference by subtracting two consecutive terms. 14 minus 4 is equivalent to 10. 30 minus 14 is equivalent to 16. 52 minus 30 is equivalent to 22. 80 minus 52 is equivalent to 28. Since our first difference is not yet common, we move to the second difference. So 16 minus 10 is equivalent to 6, and 22 and 16 is equivalent to 6. 28 minus 22 is equivalent to 6. So the second difference is already common, so our common difference is 6. So step number 3. Using the table that you made in step 1, use the general formula for linear sequence to form an equation, and it is an squared plus bn plus c is equivalent to an. So at n is equivalent to 1, an would be 4. So substitute and simplify, we have a plus b plus c is equivalent to 4. And that would be our equation number 1. At an is equivalent to 14, our n would be 2. So substitute and simplify, we have 4a plus 2b plus c is equivalent to 14. And that will be our equation number 2. So at n is equivalent to 3, our an would be 30. So substitute and simplify, we have 9a plus 3b plus c is equivalent to 30. And that would be our equation number 3. So we form 3 equations from the table to solve for the unknown because there are also 3 unknowns. Step number 4. Solve for the unknown variables. So first, eliminating C. 4a plus 2b plus c is equivalent to 14 minus a plus b plus c is equals to 4. The result will be 3a plus b is equivalent to 10, and that will be our equation number 4. So I subtracted two pairs of equation, example, equation number 2 and equation number 1, and now I will subtract equation number 3 and equation number 2. So, 9a plus 3b plus c is equivalent to 30 minus 4a plus 2b plus c is equivalent to 14 will result to 5a plus b is equivalent to 16, and that will be my equation number 5 so that I can eliminate b. So, eliminating b. 5a plus b is equivalent to 16 minus 3a plus b is equivalent to 10. So I subtracted equation number 5 and equation number 4. The result will be 2a is equivalent to 6. And since I only need the value of a, so I will solve for a. 2a is equivalent to 6. Divide both sides by 2, so a is equivalent to 3. And I will solve for b. Using equation number 4, I will substitute the value of a to find the value of b. So 3a plus b is equivalent to 3. And since a is equivalent to 3, substitute, then simplify, b is equivalent to 1. And then solve for c. Using equation number 1, substitute the value of a and b to find c. So since my a is 3 and b is equivalent to 1, so simplify, I have c is equivalent to 0. Substitute the value to the general form to obtain a formula in finding the nth term. So we all know that our quadratic formula is an squared plus bn plus c is equivalent to an. Substitute the value of a and b and c to the general form. So we have 3n squared plus 1n plus 0 is equivalent to an. And that will be our general formula. And 51st term, we substitute n is equivalent to 40 and n is equivalent to 51. So first, n is equivalent to 40. Substitute 40, we have 3 quantity 40 squared plus 40. Simplify, we have a sub 40 is equivalent to 4,840. So our 40th term of the sequence is 4,840. And if n is equivalent to 51, an is equivalent to 3n squared plus n, we substitute 51. So simplify, we have our 51st term is 7,843. Let's try this. Follow the steps in finding the general formula. Answer the following. The answer key is found at the last part of the presentation. On to cubic sequence. What is cubic sequence? How does it differ from the two sequences? Cubic sequence is similar with the two. However, its common difference falls on the third difference. So examples. First is, find the general term and the 10th and 20th term of the given sequence in example A, number 8. Second is, find the general term and the 6th and 16th term of the sequence in example A, number 9. We'll try to answer example number 1. So, recall step number 1, make a table with a heading n and an, where n represents the domain and an which represents the term value. So if our n is 1, our first term is 11. If n is 2, our second term is 27, and so on. So again, what is our second step? Our second step is subtracting two consecutive terms. So 27 minus 11 is equivalent to 16. 59 minus 27 is equivalent to 32, and so on. And since it is not yet common, we get the second difference. So our second difference is 32 minus 16 is equivalent to 16. 54 minus 32 is equivalent to 22. And 82 minus 54 is equivalent to 28. And since it is not yet common, we proceed to the third difference. Our third difference is 6. And since it is common, so it is a cubic sequence. Using the table that you made in step 1, use the general formula for cubic sequence to form an equation. And it is an cubed plus bn squared plus cn plus d is equivalent to an. And that is obviously our step number 3. So, we form 4 equations from the table to solve for the unknown. At n equivalent to 1, our an would be 11. So, substitute, we have a plus b plus c plus d is equivalent to 11. And that would be our equation number 1. And if n is equivalent to 2, our an would be 27. Substitute n and an. Simplify, we have 8a plus 4b plus 2c plus d is equivalent to 27. And that would be our equation number 2. And if our n is equivalent to 3, our an would be 59. Substitute the values. So simplify, we have 27a plus 9b plus 3c plus d is equivalent to 30, and that would be our equation number 3. And last, if our n is equivalent to 4, our an would be 113. So substitute and simplify, we have 64a plus 16b plus 4b plus d is equivalent to 113. And that would be our equation number 4. Number 4, solve for the unknown variables. So, first we will be eliminating d. So we subtract two pairs of equation. Example, equation number 2 and equation number 1, equation number 3 and equation number 2, and equation 4 and equation number 3. So to tell you what I'm talking about, here it is. 8a plus 4b plus 2c plus d is equivalent to 27 minus the first equation, a plus b plus c plus d is equivalent to 11. Subtract both equations, we have 7a plus 3b plus c is equivalent to 16. And that will serve as my equation number 5. And pairing equation number 3 and equation number 2, I will subtract both equations. So 27a plus 9b plus 3c plus d is equivalent to 59 minus 8a plus 4b plus 2c plus d is equivalent to 27. Subtract the both equation, we have 19a plus 5b plus c is equivalent to 32. And that would be my equation number 6. And lastly, I will pair equation number 4 and equation number 3. 64a plus 16b plus 4c plus d is equivalent to 113 minus 27a plus 9b plus 3c plus d is equivalent to 59. So the result will be 37a plus 7b plus c is equivalent to 59. And that would be my equation number 7. So from the 3 equations, I can now eliminate c. Eliminating c. Pairing up equation number 6 and equation number 5, subtract both equations, we have 12a plus 2b is equivalent to 16, and that will serve as my equation number 8. And equation number 7 and equation number 6, subtract both equations, we have 18a plus 2b is equivalent to 22, and that would be my equation number 9. As you can see, equation number 9 and equation number 8, I can now eliminate b. So eliminating b. 18a plus 2b is equivalent to 22 minus 12a plus 2b is equivalent to 16. The answer would be 6a is equivalent to 6, and that would be my equation number 10. And since I am only finding the value of a, not the value of 6a, I will solve for a. So 6a is equivalent to 6, divide both sides by 6, a is equivalent to 1. And solve for b, using equation number 8, substitute the value of a to find b. So I know that my a is equivalent to 1, so 12 times 1 plus 2b is equivalent to 16. Simplify, I have b is equivalent to 2. And since I have the value of a and b, I can now find the value of c. So solve for c. Using equation number 5, substitute the value of a and b to find c. So I know that my a is equivalent to 1 and b is equivalent to 2. So substitute 7 times 1 plus 3 times 2 plus c is equivalent to 16. And simplify, I have C is equivalent to 16 minus 13. C is equivalent to 3. And lastly, solve for D. Using equation number 1, substitute the value of A, B, and C to find D. A is equivalent to 1, B is equivalent to 2, C is equivalent to 3. So, 1 plus 2 plus 3 plus D is equivalent to 11. Simplify, D is equivalent to 11 minus 6, so D would be equivalent to 5. So, I already have the value of unknowns. So, we'll proceed to step number 5. Substitute the value to the general form to obtain a formula in finding the nth term. So A is equivalent to 1, B is equivalent to 2, C is equivalent to 3, and D is equivalent to 5. Substitute, we have 1n cubed plus 2n squared plus 3n plus 5 is equivalent to an. Simplify, our general formula would be n cubed plus 2n squared plus 3n plus 5 is equivalent to an. So to find the 10th and 20th term, we substitute n is equivalent to 10 and n is equivalent to 20. So first, if n is equivalent to 10, our an would be quantity 10 cubed plus 2 quantity 10 squared plus 3 times 10 plus 5. Simplify, our a sub 10 is equivalent to 1235. So that means that is our 10th term. And if our n is equivalent to 20, our an would be 20 cubed plus 2 quantities 20 squared plus 3 times 20 plus 5. Simplify, our a sub 20 would be 8,865. And that would be our 20th term. Wow, so you've learned about cubic sequence. To test your understanding, let's try this. Follow the steps in finding the general formula and answer this cubic sequence. The answer key is found at the last part of this video. Here are the answers for the practice exercises. Thanks for watching.